It's the most rebellious planet in the solar system, the farthest from the Sun, yet boasts a molten core reaching 7,000 degrees Celsius, while its surface is colder than Antarctica. Even more bizarrely, this planet teems with supersonic winds reaching 2,160 kilometers per hour, ripping any life form to shreds in an instant. It's Neptune, a planet where even viruses can't survive. A gas giant, Neptune may appear calm and azure, but it wasn't until the Voyager 2 flyby in 1989 that humanity discovered its true potential as a violent and threatening planet. On the surface of this 49,500 km diameter planet, a black vortex large enough to swallow Earth whole drifts. Even more terrifying, its winds reach 2,400 kilometers per hour, 20 times stronger than Earth's strongest hurricanes. Even more bizarre, these storms are rife with a unique substance called superionic water. Water molecules, under pressures of millions of atmospheres, are condensing into a vortex of water. Below the tower, only atomic nuclei and electrons remain, acting like both solid and liquid, possessing exceptional conductivity and fluidity. When swept by hurricane-force winds, this substance instantly disintegrates anything approaching into its atomic state. Neptune's horrors don't end there. Its surface temperature plummets to -218 degrees Celsius, where even oxygen and carbon dioxide become solid. Even more deadly, its atmosphere is 85% hydrogen, 10% to 30% helium, and the remainder is methane and hydrogen sulfide. This mixture instantly corrodes the lungs upon inhalation, and even Earth's most resilient water bears wouldn't survive for more than a tenth of a second. Even more remarkable is that despite its vast distance from the Sun, Neptune's interior is incredibly warm, with core temperatures reaching 7,000 degrees Celsius, hotter than the Sun's surface. Astronomers speculate that this is due to the intense internal activity on Neptune, which releases vast amounts of heat from its core. Under these extreme pressures and temperatures, its atoms are compressed into diamonds, which could form a vast ocean within Neptune. As the diamond crystals rise, they release immense amounts of heat. Not only is the temperature abnormal, but Neptune's magnetic field is also extremely strange. Normally, the axis of a planet's magnetic field is roughly aligned with its rotational axis. For example, Earth's magnetic declination is only about 11 degrees. However, Neptune's magnetic field axis deviates from its rotational axis by 47 degrees, meaning its magnetic poles are not at the North Pole or South Pole, but near the equator. This unusual magnetic field can cause the radiation belts to be distributed chaotically, and if a spacecraft intrudes upon them, its instruments may instantly malfunction. Even more amazing is Neptune's ring system. Although these rings are dark and thin, making them almost impossible to observe, one ring in particular is particularly amazing, the Adam's ring. It is not a complete circle, but is composed of several bright arcs, like a broken pearl necklace, gleaming in the dark. Even more amazing is that these arcs do not disperse. Astronomers speculate that this may be a miracle caused by the combined gravitational pull of Neptune's satellites. Triton is Neptune's most unique satellite. Larger than Pluto, it orbits in a direction different from Neptune's other moons, moving in the opposite direction of Neptune's rotation. This suggests it was likely not originally a satellite of Neptune, but rather was captured from the Kuiper belt by Neptune's gravity. Above Triton, unusually active cryovolcanoes erupt not from molten lava but from liquid methane and ice crystals at temperatures exceeding -200 degrees Celsius. Even more astonishing is that the cryovolcanoes continue to operate in such low temperatures, a rarity among known satellites in the solar system. Today, Neptune, carrying its secrets, spins in darkness 4.5 billion kilometers away, its year lasting 165 Earth years. Since its discovery, it has only orbited the Sun once. The storms raging on its surface could linger for centuries or vanish in a split second. We know less about it than we do about the surface of the moon, but it is precisely this unknown that makes it the solar system's most fascinating mystery.